In the 1880s, David Gill, a master clockmaker from Aberdeen, Scotland, applied his precision clockmaking machinery to astronomical telescopes, and ironically enough, offered a way of showing that the stars were not all moving in clock-like unison. Gill was a pioneer in the field of astrophotography. In the mid-1860s, still an amateur astronomer working in his father's back garden, he built a tracking mount for his 30-centimeter, 12-inch reflecting telescope and used it to photograph the moon with a clarity that had never been seen before. The photographs earned Gill a fellowship in the Royal Astronomical Society, and by 1872, his first job as a professional astronomer at the Cape Observatory in Aberdeen. Gill applied clockwork tracking mechanisms to telescope mounts so that the telescope could move in near-perfect harmony with the rotation of Earth. This allowed the instrument to remain fixed and focused on a single patch of sky. Imaging faint celestial light required exposures of several minutes at least, and poor tracking meant that early star photographs were mostly incomprehensible blurs. In 1879, Gill became the chief astronomer at the Cape Observatory in South Africa. By now, he was using the latest dry plate system, a photographic plate ready coated in light-sensitive chemicals, which he employed to capture the great comet that appeared over the southern hemisphere in 1882. Working in partnership with the Dutch astronomer Jacobus Kapteyn, Gill spent the best part of the next 2 decades creating a photographic record of the southern sky. Gill also became a key figure in the Carte du Ciel, Map of the Sky project, a global collaboration of observatories begun in 1887 with the aim of making a definitive photographic map of the stars. This ambitious, expensive, and decades-long project involved teams of human computers that would measure the plates by hand. The accurate maps produced by Gill's photographic techniques may seem fairly unremarkable today, but at the turn of the 20th century, they were the first reliable means for showing the proper motion of nearby stars relative to more distant ones. This information was invaluable for measuring stellar distances on a large scale, and it began to reveal to astronomers the true scale of the galaxy and the universe beyond. The eldest son of a successful clockmaker, David Gill was destined to take over the family business. However, while at the University of Aberdeen, he became a student of the great physicist James Clerk Maxwell, whose lectures gave Gill a passion for astronomy. When offered a job as a professional astronomer in 1872, Gill sold the family business and began work at the Cape Observatory, Aberdeen. As well as his pioneering work in astrophotography, Gill developed the use of the heliometer, a device for measuring stellar parallax. His measurements, used in conjunction with his star maps, did much to reveal the distances between stars. By the time he left the Cape Observatory in 1906, Gill was a renowned astronomer. In one of his final jobs, the government consulted him on the implementation of daylight saving hours.